Welcome students. In previous class we have seen about what is impact, what are the different types of impact, what is coefficient of restitution, what is restitution, and what are different types of restitution. Now let us apply those concepts in the problems. The first problem is two spheres having mass 4 kg and 3 kg move towards each other with velocities 8 meter per second and 12 meter per second respectively. If coefficient of restitution is 0.8, determine the velocities of two masses after collision and the loss of kinetic energy. So you can see here there are two bodies of mass 4 kg and 3 kg and they are moving towards each other, and at some particular point they will collide with each other having a coefficient of restitution as 0.8. Now what we need to do, we need to determine what will be the velocities of these two bodies after their collision and what is the loss of kinetic energy. So we have seen in our previous discussion that when E is between 0 and 1, that is, as in this case it is 0.8, we have two things to be remembered. The first thing was momentum is conserved, that is initial momentum is equal to final momentum, and second thing is there is a change in kinetic energy. So let's start with the first point, that is initial momentum equal to final momentum. So momentum, we know that it is written as mass into velocity. So as it is initial momentum, it will be initial velocity of A and initial velocity of B. So this term ma into ua is the momentum for body A and this is the momentum for body B. Similarly, ma into va is the momentum for body A and mb into vb is momentum for body B. Now let us substitute whatever values we have. For example, mass of A we are already given to us as 4 kg. UA, that is initial velocity of body A, that is also given to us as 8 meter per second. Then mass of B, it is given to us as 3 kg. UB, initial velocity of ball B, which is given to us as 12 meter per second. On the right hand side we have MA 4 kg, we have PA we require to find out, MB is given as 3 kgs, and VB we are required to find out. So let us substitute whatever we know and we will get one equation as 4 into 8 plus 3 into minus 12. Now why minus 12? Because this 12 is going towards left hand side, hence it will be negative, is equal to 4VA plus 3B. On solving this further, I will get one equation as minus 4 is equal to 4VA plus 3VB, and let this be equation number 1. Now in the question we were also given that the coefficient of restitution is 0.8, and we also have our formula with us for coefficient of restitution as E is equal to velocities of separation. So we write it as VB minus VA divided by velocities of approach. So we write it as UA minus UB. So let us use this equation. So we have E is equal to VB minus VA divided by UA minus UB. Now in this equation, the value of E is known to us. VB we are required to find out, let it be as it is. VA also we are required to find out, let it be as it is. UA we are given to us as 8 meter per second and UB is given to us as minus 12 meter per second because it is going towards left side. So just substituting these values, I will get the equation as 0.8 is equal to VB minus VA divided by 8 minus of minus 12. On solving it further, I will get the equation as VB minus VA is equal to 16. Let this be equation number 2. Now from equation 1 and 2, there are two unknowns, that is VA, VB. Here also there are two unknowns, VB and VA. So two equations and two unknowns, we can solve this equation simultaneously. So solving equations 1 and 2 simultaneously, we get the values of VA as minus 7.42 meter per second and VB as 8.57 meter per second. This completes the first part of the solution, which says to determine velocities of two masses after collision. Now, next part is to find out loss of kinetic energy. Loss of kinetic energy means what is the initial kinetic energy, what is the final kinetic energy, the difference between the two will give us the loss. So let us start with the first part, that is finding out initial kinetic energy of the bodies. So we have initial kinetic energy is equal to half mv square. So in place of V I am writing U because it is the initial kinetic energy. Similarly for B I will be writing mb ub square. Substituting the values, I will get the value of initial kinetic energy as 344 joules. Now similarly I will find out the final kinetic energy. The only change will be in place of U it will be V. So MAVA square plus MBVB square. Substituting the values, because I now know the values of VA and VB. So substituting the values, I will get the answer for final kinetic energy as 220.28 joules. Now what was our requirement? Our requirement was loss of kinetic energy. So loss means initial kinetic energy minus final kinetic energy. So on substituting it, I will get the answer for loss of kinetic energy as 123.71 joules, and this completes the solution. Thank you.